Hello everybody, thank you very much for the invitation and thank you for comSysto to organize this event. My name is Cristian Klein, I am Chief Architect at SimScale. We are a startup that aims at disrupting the current computer-aided engineering market, and in particular we would like to make computer simulation the standard tool in product development. So I divided my talk into two parts, the why and what, and then in the second part I'm going to go down a little bit in telling you more about the technicalities and the challenges that we are facing. So on a very high level, every single business, in order to stay competitive, basically implements these four actions. They need to observe their competitive environment, the market, their internal environment. They need to orient, so to analyze and get the right signals. They need to decide what to do in order to improve or to move in this environment, and then they need to act on this. And the faster you go around this loop, the quicker you move in this environment and the better are your chances that you stay ahead of competition. So when we're talking about engineering a new product, say for example you want to have a mobile phone that will be released on the market, the way this generally works is that you get some kind of specifications, like if I drop the mobile phone from 1 meter, it has to not crack. And then you go ahead and do a design, and then you would go and prototype one of these designs and check, does it actually do a drop test by hand, does it actually break or not? And if you notice it breaks, well, tough luck, you have to go and redesign your product, you need to have a new prototype, and so on. And as you can feel, going through this loop is quite slow. So you cannot move a lot, you cannot try different designs out, every single test of the design is quite expensive. So what you would rather like to do is to go really quickly and just design your product. This is already done in virtual space thanks to computer-aided design, CAD. And then why not use this CAD model that is already digitalized in the computer and do a simulation, a mechanical simulation. So for example, if you're designing a heat exchanger, does actually enough heat get transferred from one liquid to another? You don't have to build the heat exchanger for this, you can just simulate it. And now, I'm sure that you have all heard about computer-aided engineering. This is nothing new, it has been around for at least 30 to 40 years. The problem is that it hasn't really penetrated the market yet. So, if you look a little bit at the market, at the landscape, it's more like aeronautics that have adopted it. Obviously, a plane is quite expensive to prototype, you cannot just build planes every single day, so it makes a lot of sense to rather do it on the computer first. And then it's also a little bit automotive. For the same reasons, it's kind of expensive to build a car and to crash it against the wall. You might rather want to try that first in the computer world. But we would really like for computer-aided engineering to become the standard tool in every kind of market. And we have identified mainly three barriers to achieving this. So the first would be the high hardware cost. So if you have, for example, an engineering studio that is often just a one-man show, he cannot just afford to buy a whole cluster of hardware and then operate that hardware and so on. Let's not forget that simulation is also a fairly special domain because it is very compute and storage intensive, right? Because you need to take your car, your domain, you need to discretize it to choose very many dots and then do a lot of computation around these dots. Obviously, the more dots you have, the better the precision, the more meaningful the results. And so this requires a lot of computations and generates a lot of data. But the second barrier is high licensing cost. So for those of you familiar with this domain, I'm sure you are aware that it's more like a 5-digit figure per seat to buy computer-aided engineering software. So again, for a one-man show, this is a huge cost. But you observe that these two problems are kind of, you just can throw money at the problem, but then there is this last problem that is really bothering us, the difficulty of setting up a simulation. So it's quite easy to just set up a simulation and get some colorful pictures at the end. The problem is it's really difficult to set up the simulation so as to get meaningful results. So what I mean by meaningful results is actually something that allows you afterwards to drive your design process, to know where should I optimize my design. Should I put a bit more plastic here maybe, or should I perhaps use a completely different material in order for the drop test to pass? And yeah, it's not easy to do that. The skills required for that are quite high. So in order to break these barriers, SimScale operates on 3 fronts. First of all, we provide you with 3D simulation in a browser. That's it. You just take the newest browser, Chrome or Firefox or whatever, that has OpenGL support, and then you just point it towards our website, and there you can do pre-processing, so uploading your CAD model, meshing it. You can do simulation, so we deal with all the hardware that you need behind the scenes, and then you do also post-processing, so getting the colorful pictures that drive your design. With respect to cost, to licensing, we offer you a pay-as-you-go model. So if you're a small engineering studio and require only 1 simulation per week, so to speak, then you would pay very little for this. We currently charge by the number of core hours that the simulation is consuming. So then if you only simulate every once in a while, you would pay very little for this. On the other hand, as you grow and you require more and more simulations, then of course you would also have to pay up. Maybe in the end we would go to a comparable figure to what is already in the market, but up to when you reach that figure, you can adapt your cost to what your actual business has as revenue. And then with respect to the difficulty of setting up simulation, our platform has been thought with a collaboration feature from the ground up. So you can share projects. We recently launched a forum, and then if at some point you just struggle to create the meaningful simulation, you can share it via the forum. Somebody else may import it. They may highlight like, oh, you have a small flaw. You have a small flaw in your simulation. You should probably put there a constraint or here a boundary condition and so on. And then they share back the project to you and allow you to improve it. And this is how we kind of do a crowdsourcing way of really distributing this simulation know-how among the users and our customers. But this, of course, would not be quite enough, so we are seeding this with some library projects. These are projects that are offered by us, that have been developed by professional engineers that also are with 1 foot in actual product development. And so, for example, if you, let's say tomorrow, want to design the next generation knee protection for roller skates, then you might just be better off starting from our helmet project. So this is what happens to a head if it bounces against the wall without a helmet. This red thingy is not making doctors happy. And whereas with a helmet you can see that this whole effort is being better spread around the cranium, so most likely your head will survive it a bit better. So then if you just want to go and design a knee protection, you could just download this simulation and use this as a template and just replace the skull and the helmet with knee protection and a knee, and you're already on the way to having your first successful simulation. Okay, so this is pretty much what we do and why we do it. Let me now go a little bit more technical. So from a high-level overview, if I were to put the users and the customers on the left and then the hardware on the right. We have the users that don't require anything but internet access and a modern browser. They don't have to think about what hardware to acquire. They don't have to think about software updates. They don't have to hire an IT specialist to maintain their computers. All that really boils down to having a modern browser. Then we have our front end. So this is basically a single application web page, a single page application, sorry. In order to give you as much as possible a desktop experience when accessing our website. And of course we have fancy features like doing all the requests asynchronously, so that we hide this experience that, okay, there has to go requests back and forth between you and our server. So we really try to give as much as possible a desktop experience. And then all these requests, so from the front end, they are bouncing off our web service, which is kind of our core. That's where the data management is happening. That's where the coordinating of the simulation workflow happens. That's when backups are done, load balancing, and so on. And in the end, it is orchestrating simulations so that they can run on the computer-aided engineering Kai backend. And to this end, we're using infrastructure as a service cloud provider. So we're running on Amazon EC2 in order to run the number crunching, the heavy computing simulations. And so as the chief backend and cloud architect, I'm working on the part that is kind of the furthest away from the customer. This doesn't mean that I don't have to, like Juan said, I'm also part of the sales in a way. And just in case you're asking yourself, how does my daily job feel like? I don't know if you're aware of the viral video that has been published a few years ago, where basically somebody changes the wheel of the car while the car is driving. This is pretty much how it feels to work in backend, especially if you are in software as a service, because there is just an expectation of 24/7 service. You cannot just tell the users, well, you know what, we're going to have tomorrow a downtime because we're updating our platform. Yeah, I mean, you could do that, but then next thing the sales are going to knock on my door and ask for some clarifications. And while we're changing the wheels at this car, while it's running, you might have other colleagues like the front-end team that is changing a bit the color of the car and adding a little bit of leather on the seats and, you know, making it really look nice and shiny. And, you know, your task is really simple. Just make sure that the car doesn't jiggle too much so that the color can be put nicely and evenly. So this is pretty much one hand how my job feels. On the other hand, it's really difficult to explain the customer what is exactly the value that our team brings, because I don't know if you ever had this experience, but no customer calls to say, hey, your platform is going really fast today, thank you so much. I didn't have any of these calls. Maybe any of you feels differently. They're only going to call when your platform is down, or when it feels slow, or when there is some kind of problem. Yeah. So, but still, we realized that there is a lot of money that goes in our backend team, and so it was important for our customers and at the corporate level to understand why exactly is this money flowing in the backend team, which is why I published a blog post that tries to really explain the customer what exactly is he getting for that money, what are the problems that he would have to deal, and we are doing it for themselves. And essentially we boiled them down to 5 topics: to security, data storage, software updates, performance upgrades, and hardware provisioning, about which I'm going to tell you in the next slides about. So with respect to security, the thing is that the customers entrust us with their most precious data, right? So the design of a product, that is definitely something that if it goes away, that our customers would lose their competitive edge. They could be really quickly copied by their competitors. So they absolutely need to make sure that their data is in safe hands. And as a company that lives in Germany and is targeting German customers, this is in particular difficult. There have been quite a lot of news about industrial espionage lately, so we need to show our customers that we're making a double extra effort to satisfy their safety needs. And moreover, this is also challenging because traditionally this industry is just used to getting their software on a computer, on a desktop computer, preferably that is just cut away from the internet. And so they don't have this idea of, oh, my data should be given to somebody else so that they can crunch it. And this is why we have gone maybe a bit overboard with our security. So we employ encryption everywhere. When I mean everywhere, that's really everywhere. So when the data between the browser and the front end, our web server, we have SSL, highest grade encryption to transfer the data. The data on the server itself, the hard drive is encrypted. In fact, if the server goes down, then somebody has to manually type in the passwords to decrypt the hard drive. So it's as if we even mistrusted the data center where we're hosting it. And then if the data again is transferred encrypted into the cloud where the number crunching is happening, the hard drive of those instances is also encrypted. So again, to make it really difficult for somebody to understand what exactly is happening on the instances that we're having in the cloud. And in fact, the decryption key of those instance hard drives is also being pushed for our web service. So right now, I could just give you all our image that we're using in the cloud. You would probably not be able to use it because it would just look like random data to you. Whereas since we have the encryption key, actually can make sense out of it. Okay, so this is one part, of course, using encryption, but on the other hand, you can also misuse encryption or not use it quite correctly. Which is why, to make sure that our platform is secure, we also recently hired a penetration testing consultancy company. So for those of you who are not familiar with this, they basically take the role of attackers and try to preemptively strike attacks on our platform before the bad guys have a chance to do it. And then they might come up with stuff like, oh, here you have forgotten to update your certificate, or here you have a vulnerability, you might want to patch it as quickly as possible. And again, here we notice that not only that this is valuable for the customers, because no individual customer can afford going that deep with security, but furthermore, we can do a lot of economy of scale because we do this only once for all our customers. Whereas, like I said, if any of our customers wanted to be as pedantic as us about security, they would have to pay a quite hefty fine and hefty fee. And this is actually quite one of our selling points. So whenever somebody says, yeah, I don't know the cloud, it sounds a bit insecure, where is my data? We just ask them, how many people are working for security in your company? In ours, there are 2 full-time employees working on this. And that kind of makes them realize that, okay, you probably deserve our money, guys. Okay, the second issue then is data storage. So this is kind of complementary to the security issue I have just raised. Now the problem is not that we need to have the data safely, but we need to make sure, before we need to make sure that the data doesn't get in the wrong hands, now we need to make sure that the data doesn't get lost. Again, because they invested a considerable time in setting up their simulation, the simulation have taken a lot of time to execute, they have already gained a little bit of insight. If tomorrow we'll call them and tell them, oops, we deleted your simulation, I'm afraid, they won't be happy either. And of course, this all without compromising in any way the performance or the security of our platform. So the way we do this on a technical level is that we have been moving from this mentality of having server as pets to having server as kettles. So for those of you who are not familiar with this metaphor, it used to be that, oh, this server, you would grow it, you would take care of it, you would maintain it, it would be something really precious, it would be something you take care of. Whereas now server is more like, don't store any valuable, we clearly separate servers on which data is stored and on which just data isn't stored. And for those servers that are not really storing data, they're just running code and stuff like this, yeah, if it doesn't go well, if it misbehaves from some value, if it gets sick, just slaughter it and replace it with a new one. Another metaphor that I heard about this is not having snowflake server, right? So the second the snowflake, you touch the snowflake, it just melts away and something goes wrong. And as a solution, we have started pushing our data into Amazon. They have a nice service called Simple Storage Service, S3, with of course client-side encryption, because again, we want to control what happens to this data. We don't want Amazon to take any look at this data. And of course, there is some added complexity to this, so which is why we have an in-house developed component that we call the data manager, that makes sure it knows in what region of Amazon, in what bucket the data has been put. It stores the encryption keys and generally handles deduplication, encryption, and deduplication, compression, and encryption in this order. And upon retrieving data, it does the opposite operations. And we still have tools that operate a lot on the server's file system, in our case, basically the file system just acts as the cache. So that's where data gets downloaded, number crunching is happening with the tools, and data gets pushed back into S3. And I think deduplication was quite a buzz with respect to big data. So how do you make sure that if user A uploaded a video and user B uploaded a video, you don't store that video twice? And in our case, we realized that we don't really have to go through complicated deduplication that would regularly scan your data and so on, because we actually know when data is duplicated. We see when customers are sharing a project, when they're importing a library project and so on. And so we can just directly implement copy on write semantics, in everything. So basically, first, when a user duplicates a project, they just, for those who are more technical, we do hard links to the old files. Respectively, in the cloud, we just tell that, remember that this project is duplicate of that one. And then once either one or the other one of the users have changed their project, that's when they get their private copy of it. But until then, we don't really store anything extra. And getting a little bit even more technical, so on the high level we have our preprocessors, our solvers, and our post-processor that access data through our in-house developed data manager component. And this data manager, like I said, it stores a lot of metadata about everything that needs to be stored, such as encryption keys, such as to whom this data actually belongs, who duplicated this project, and so on. We store this in Cassandra. I don't know how many of you are using Cassandra or are familiar with it. Okay, so quite a few. So what I really like about Cassandra is that it's a multi-master solution, which means that if you kill one of the two Cassandra instances, the other one just takes over transparently. If that one comes back up, again, they catch up really quickly. So none of the two Cassandra instances is more important than the other one. Try to do something similar with PostgreSQL with the master-slave replication, and you see that if you kill the master, sure, one of the slaves will take over, but then when the master comes back up, there is such an ambiguity moment. You have like a split brain problem. Which of the two halves of the hemisphere should now take over all the operations? And with Cassandra, you don't have all this stuff. And that's where metadata gets stored, and of course our data, like I said, is in Amazon S3. And this architecture is really nice because it allows us to separate what part of our system is stateless, so again, the cattles, and what part of our system is stateful, so needs to be treated as pets. And this is considerably helping us in the next topic that I'm presenting you, so software updates. Of course, we need to be agile and we need to deploy new features as quickly as possible because otherwise we don't get new customers. So in fact, we are releasing a new version of our platform every 2 weeks. So if you are going now on our website and then go 2 weeks in another, again on our website, you basically see a completely different version of the software running out there. And of course, this has to be made without any disruptions to our customers. They have to not notice anything except, ooh, a new feature has appeared, how cool. So this used to be not that smooth in the past, but we have made considerable advancement in this respect by investing heavily in automation, right? We have to do deployments every 2 weeks. There is no purpose in making this by hand. It's not a task that is fulfilling for our DevOps engineer. It's not something where we can add business value. It's just something that we need to do. So this is why we have invested heavily in basically teaching people not to use cookbooks anymore. So I don't know who is familiar with this metaphor, but in essence, oh, we need to do a deployment. Well, I just take the deployment book out, turn to page 37, and then, okay, step 1, step 2, and so on. So we completely forbid this kind of approach, and yeah, since you already have a cookbook, why not write a script that is both human readable and machine executable, and that thing can be launched next time to really automate your deployment. And so besides automating your deployment, of course you want to make sure that what you're deploying doesn't break anything for the customer. So we have also invested heavily in testing. And so for those of you who want to go on a bit more techie side, what tools we're actually using. So all our source code and all our automation scripts are stored in Git. These are regularly pulled by Jenkins, which is a continuous integration environment. So every single hour, it's as if somebody gets our source code, tries to build it, tries to run some tests on it. I mean, basically takes the shoes of the customer and clicks around. And then if these things work out fine, then so-called Docker images, container images are being pushed so that they can be both used there in production and also for local development by the other developers that are working on their components, but they don't want to, or they don't, it would be really inefficient for them to know about all the other components around them. And so in essence, this basically means that we are optimizing our own internal ODA loop. So I don't know how many of you are familiar with Docker. It's a fairly new technology. Okay, so I prepared some slides just in case, but in that case, I think they won't be so useful. So just to give you a brief idea for the others, what it's about is that a few years ago, this trend of DevOps have emerged. So that developers don't only write code, but they're also responsible for explaining in what environment that code can run. So if, for example, I developed, an application, it's not just, okay, this is my source code, I'm done as a developer, but I also have to somehow specify this requires Java 7, or it requires Java 8, or it requires some other software. And so when virtual machines appeared for the first time, people were really happy about this because it's not so difficult to build a virtual machine image that completely engulfs the environment in which your software needs to run. However, this has proven to be with fairly high overhead, right? So creating a VM image is not very fast. It takes quite a considerable time. You duplicate the operating system, you duplicate binaries and libraries that your software might be using, which is why recently Docker emerged and containerization technologies have been developed, which basically gives your process the impression that it's alone in the system, right? It's being given a separate network stack, it's being given a separate file system, and separate IP tables. And the nice thing is that the way containers are being built is that you build them layer by layer. So you might have, say that, okay, I need an Ubuntu 14.04 layer, on top of which I put a Java layer, and then if I have some code that needs Java a component that needs Java and another component needs Java, Docker is actually built in a way that you do not have to duplicate these things. So it has again a copy and write semantics. Each one would just use the same layer of Java, but if for some reason this container changes the Java installation, no clue why this would happen, it basically gets its private copy of those files. And so again, this is very low overhead. You can basically build these containers almost as quickly as you would type make, and it allows you to be more agile and to really test this whole bundling of the software first on your laptop before shipping it out there, and also while also making sure that it will work for everybody. Okay, so much for software updates. Some of our software updates are related to performance, so just making the software faster and faster so that marketing cannot blame it on us that we don't get more customers. And we have observed that every now and then we have a problem where we need to migrate to a completely new technology, or we need to migrate to a new database schema. And I wanted to share with you a little bit how we deal with this, knowing that we have the constraints of being 24/7 online. And so we have this methodology where we first start with the old component or the old server that is using the old technology. And then at some point we start developing on writing in the new format using the new technology, but at the same time still keeping the old format. So the way it works that writes would go both to new and old, and then reads would first come from new. And in case you notice, oops, there was some problem with writing, so reads didn't work out well, then we just fall back to reading from the old technology. And this has also the big advantage that it gives you a really good chance at catching all those nasty bugs that can only be caught once your product makes it into production, such as performance bugs, right? It worked perfectly for 100 users, and you try to really check whether the new technology scales as much as possible, and then you deliver it in production and realize your CPU is just skyrocketing. And then you have a nice chance to just go back to your old server and get a bit more fresh air to check what exactly went wrong. And so afterwards, when we have gained enough confidence in the new technology, and we know for sure, okay, this is the way to go, from now on there's no reason to look back, then we can just scrape off the old technology. This is basically a garbage collection, a cleanup operation. And we found this mentality to help us go way smoother in our updates. With respect to hardware provisioning, so of course we run our number crunching in the cloud, and so we're in a sense buying, or rather leasing hardware on behalf of our customers. And we want to make sure that whenever the customer clicks on start simulation, he doesn't have to say waiting for instance acquisition. We need this experience to be as fast as possible. And so we're not really doing anything too fancy with this, maybe the standard solutions. So we're keeping some pools ready to be used, a pool of instances ready to be used, idling around for the user. And then we make sure that this pool doesn't grow too big to prevent overspending. And then when a simulation has executed, we just clean the instance, getting it ready for the next simulation. And of course, if we notice that for a certain time no simulations have arrived and the next billing hour is about to start, then we just shut down this instance. And we observe that this is again somewhere where we can do a lot of economy of scales on behalf of our customers, because if we were to deliver this software on their premises and they would only do a simulation every once in a while, they wouldn't really be able to fill those billing hours as efficiently as we do. Whereas in our position, since we're aggregating all the computation demands of all our customers, we can better pack these computations on computing resources, and so leading to savings for everyone. Okay, so some logos about our the great open source software out there that helped us realize this vision. So we're using Nginx for the entry point for the front-end servers. Cassandra in some software components. Other more legacy components are still using a Progress database, ProgressQL database. Tomcat Java is our main engine. This course is firing our forum, and then we use third-party software for solving. So OpenFOAM is quite familiar in in fluid dynamic simulation. We chose not to reinvent the wheel because there is already a lot of work that has gone into this. So we rather just are in the position where we make it easier to be used by customers. ParaView is a nice post-processing visualization tool. And so Python is basically used to glue all these things together. And as you can see, we have a plethora of open source software, and we have even more in-house developed components. And to handle all this jungle, we are using Docker in order to create harmony within the company and also on our servers. Okay, that's pretty much all I wanted to tell you. So what I really wanted to transmit you is that I feel one of the most important things in businesses is to look at your ODA loop, so observe, decide, and analyze, both externally for your customers, but also internally for yourself. And then as an SaaS provider, like we saw, we have great opportunities for savings on behalf of our customers, but this also comes at great responsibility. And then, in particular in the case of SimScale, this entails a lot of computations and a lot of data, which is likely the reason why I came here at the Big Data event. Thank you very much for your attention. I'm ready to take your questions now. Thank you.
At which layer do you actually implement that migration part? Because I guess there has to be something that actually decides to fallback read on the old and write. So you have to write something, right? Develop something that actually handles that. So which layer do you put that?
This is generally on a component-by-component decision. So if at some point, say the pre-processing guys decide from now on we're not using this for visualization anymore, we're using this other thingy, then it's their responsibility to implement this fallback. So generally the knowledge of how you migrate from the old technology to the new technology, it cannot be easily factored out. It's very case by case. So which is why, basically throughout time, in any of these things, at some point there was this migration being done. I don't know if did I answer your question?
Yes, you did.
Okay, thank you.
We could do other questions to the break. So I'm not sure.
Yes, we're kind of behind. So I would suggest we just do a short break, 15-minute break, 10-15 minutes, and we can start with the next talk. We're going to have some coffee outside and some snacks. So, thank you.